So here's another problem where we finding the gradient. We need to graph the gradient function. And notice what I've done is I've looked at where my curve's turning. They're my critical points, so I'm able to plot them out first, and I've got to get that. My curve rises, I get a curve that falls. A curve that is positive up here. When a curve falls, then my graph is negative. So my values there, because I'm graphing the derivative values, and back at 0, and after it, after this turning point, my curve rises, so it must be positive. So I've graphed it up correctly. In the next question, this one is a parabola. So our parabola only has one turning point. We know it turns there, so that's why it's matching up where it's going through the axis there. And our curve just falls, stops, and then turns. So it should have a negative gradient, a 0 gradient, then a positive gradient. So that's how we start to match it up. This time, this is a cubic curve, so our curve is a parabola. So we start to see where it's turning. So our turning points match up. It's turning there. And we got a negative gradient, so it's negative until the turning point. It rises, so positive gradient there. And then the curve falls again, so we've got a negative gradient. A few more turning points this time in this one. So you can see it turns because it's negative, 0, positive, and then the gradient's negative, and then turns, and then it's positive again. So we see where it turns 3 times. Turns a bit better there, so let's try and match it up, and that's why I don't mind putting little dots there so we can show that where it turns. And the curve is falling to this turning point, so it's a negative curve. Then it rises, so it's positive. Then it falls, so it's negative again. And then it matches up where it's going through and 0 again when it turns, and we get a positive gradient. This time it's a little bit different, because if we have a look at our curve, it rises from a very sharp point here. So we actually get looking at this going, well, wait on, if I drew a tangent to that, so if I put a curve, if I put a line there, it would be vertical. Now, hopefully remember that we can't get we can't get the gradient of a vertical line. So that's why we've got the blue line here, which is indicating an asymptote. Because at that point there, we get a point where our line becomes vertical, so we can't get a gradient there. Which means we can't draw a derivative function that complete and it matches up there. So we can't have that. So we have a problem. So what we want to do again, match up our stationary points, because the curve rises and then falls, but then it keeps falling and then rises again. So you can see where our graph should be positive, should be negative, but also because it's getting closer to a vertical line, we know a vertical line has a very large, an almost vertical line has a very large gradient. If it's horizontal, the gradient's 0, but we don't get it. So if we get a very very steep line, the gradient starts to tend towards infinity. Either if it's rising, so it would be positive, or if it's falling, it would be negative. So that's why you can see the curve starting to go towards positive infinity here, because the curve's getting towards a vertical line, and it's a positive gradient. Well, it's coming from a vertical line, which is positive, and it's turning towards a vertical line and it's falling. So that's why it's going to negative infinity. Again, it's coming from a negative. It's coming from in terms of a negative because the curve's falling. So that's why it's coming from negative infinity through 0 and then going to positive infinity. So it's because the curve is getting towards a vertical line there. Again, you start to see it with these ones. So the curve, when it comes there, is coming from a point where it was actually stopped. So that's why this point starts from 0 there. Our other turning point is there, and then it finishes there where it's coming up to a turning point as well. So that's why it finishes it at 0. So there's our critical points there. we have vertical tangents, vertical lines here, vertical tangent being we can draw, and so we get an asymptote for our derivative function. So the curve falls, so that's why it's going to negative infinity. It's falling still, so that's why it's negative, but it's flattening out. So even though it's negative, the curve's coming towards turning, so it's going to be coming to zero there. And then it rises, and it rises till it's coming extremely steep, so it's going to be going towards positive infinity, and this one's coming from positive infinity to a point where it's going to be at zero. And here's another one where we're looking at our stationary points and matching them up first. So our curve turns, so we know our first derivative would be 0, because at those points we're getting a change in sign of our gradient. So it's curve is rising, so it's a positive gradient, but then it falls to that point, so a negative gradient. Rises again, so positive gradient. Falls again, so negative gradient there, and then rises after the stationary point, so it rises again. So there's a few ideas about how to graph these types of functions. Some are easy, some are hard, and we've got to be careful about looking at what our values of our gradient are tending to do.